Happy morning, students. In this session, we are going to learn about different types of chemical reactions. A lot of chemical reactions occur in our daily life. Cooking of food, burning of LPG, rusting of iron, bursting of crackers, decomposition of vegetable matter are few examples of the chemical reactions. Each of these reaction occurs at different condition. Based on the different condition, the chemical reactions are classified into 5 types. They are combination, decomposition, displacement, double displacement, and oxidation reduction reaction, which is called together as redox reaction. Let us learn about each type of chemical reaction in detail. The first reaction is combination reaction. The reaction in which two or more reactants combines together to form a single product are called as combination reaction. Few examples for the combination reaction are burning of magnesium ribbon. Magnesium ribbon burns in oxygen with a dazzling white flame to form a white powder magnesium oxide. Mg plus O2 gives MgO. Magnesium ribbon can also burn in nitrogen to form a product called as magnesium nitride. Mg plus N2 gives Mg3N2. The reaction of iron with sulfur is also a combination reaction. Iron fillings can react with yellow color sulfur powder on heating and form a black colored product iron sulfide. In this example, ammonium chloride is obtained by combining ammonia with hydrogen chloride. The next example is reaction of quicklime with water. Quicklime, which is calcium oxide, on adding water forms slaked lime, which is calcium hydroxide, with the release of heat. The equation is CaO plus H2O gives CaOH twice, which is calcium hydroxide, and heat is released in this reaction. In this combination reaction, slaked lime is formed. One of the application of slaked lime is it is used in whitewashing. A slaked lime, when applied to the walls for whitewashing, reacts with carbon dioxide present in the atmosphere and forms calcium carbonate, which gives shiny appearance to these walls. This slaked lime, when allowed to stand for some time, forms a clear transparent layer on the top, which is called as lime water. This lime water is used for testing the evolution of carbon dioxide in any chemical reaction, as carbon dioxide is a colorless, odorless gas which is difficult to identify by us. So by performing the test, its evolution can be identified. So carbon dioxide, on passing into lime water, turns it into milky by the formation of CaCO3. This reaction makes the wall shiny due to the formation of calcium carbonate. The equation is CaOH twice plus CO2 gives CaCO3 plus H2O. In all this reaction, energy is released in the form of heat or light. Such type of combination reaction where energy is released is called as exothermic reaction. The best example is respiration reaction. The food taken by us gets digested and converted to glucose, which is stored in the cells of our body. Oxygen inhaled during respiration process combines with glucose present in the body cells and releases energy in the form of ATP along with CO2 and H2O. As energy is released in this reaction, respiration is considered as an exothermic reaction. Even the reaction of quicklime with water also releases heat. Burning of fuels like coal, petroleum and LPG, burning of natural gas methane and dilution of sodium hydroxide in water releases lot of heat energy. So these combination reactions are also called as exothermic reaction. Combination reaction are also referred as synthesis reaction. Other examples are formation of water, formation of sodium chloride, photosynthesis reaction, where two reactants combines together to form a new product. The second type of chemical reaction is decomposition reaction. Here, a single reactant breaks down to give two or more product. If the decomposition reaction happens with the help of heat, then it is called thermal decomposition. If it occurs with the help of light, then that type of decomposition is called as photochemical decomposition. If it occurs with the help of electricity, then the decomposition reaction is called electrolytic decomposition or electrolysis. The first example for thermal decomposition is breaking of limestone, which is CaCO3. On heating the CaCO3, it breaks to form calcium oxide CaO and carbon dioxide gas is released. It will be interesting to know about the lime cycle. Calcium oxide, which is quicklime, formed from thermal decomposition of calcium carbonate, which is limestone, combines with water to form slaked lime CaOH twice. This CaOH twice, on reacting with carbon dioxide, again forms limestone CaCO3. This calcium carbonate is a chemical name of limestone, marble, and also chalk piece. The second example is heating of ferrous sulfate crystals FeSO4.7H2O, which is pale green in color. It decomposes on heating and forms white anhydrous FeSO4 by the loss of 7 water molecules. On further heating, FeSO4 decomposes to form reddish brown ferric oxide Fe2O3 with the release of pungent smelling gases SO2 and SO3. The third example is heating of lead nitrate. PbNO3 twice decomposes on heating to form PbO, which is lead oxide, with the release of brown fumes of NO2 and O2 gases. PbNO3 twice on heating gives PbO plus NO2 plus O2. The next example, green color copper carbonate decomposes on heating to form black colored copper oxide with the release of carbon dioxide. Here, the blue colored copper sulfate crystals on heating gives out water molecules and forms white anhydrous copper sulfate. Second type of decomposition is electrolytic decomposition. In this example, water undergoes electrolysis and releases hydrogen and oxygen gas. The water is taken as an electrolyte and filled in a beaker along with few drops of sulfuric acid to make it more conducting. Two carbon rods that acts as an anode and cathode is fixed inside the beaker, and two test tube is carefully inverted over the rods to collect the gases released from electrolysis of water. On passing electricity, the water gets decomposed and releases hydrogen gas in the form of bubbles that is collected near the cathode, and oxygen gas is collected near the anode. Hydrogen gas was seen to have double the volume of oxygen gas because the ratio of hydrogen to oxygen to form water is 2:1. In this example, sodium chloride on passing electric current decomposes to form sodium and chlorine gas. The third type of decomposition is photochemical decomposition, where the reactants undergoes decomposition with the help of light. When white color silver chloride AgCl is kept under sunlight, it decomposes to form grayish white silver along with yellowish green chlorine. When pale yellow colored silver bromide AgBr is kept under light, it decomposes to form grayish white silver along with reddish brown bromine. This photochemical decomposition of silver chloride and silver bromide is used in the black and white photography. Photographic film contains photosensitive coatings of silver bromide which decomposes when exposed to light. All the decomposition reactions are considered to be opposite of combination reaction. In combination, the reactants are combined together to form a single product with the release of energy. But in decomposition, a single reactant gets decomposed to form two or more products with the absorption of energy. So when energy is released, it is called exothermic reaction, and when energy is absorbed, it is endothermic reaction.